It is a problem. Yes, it's a problem.
I should read
3
all
weeks.
over again.
3 weeks.
Good idea.
You should study hard for 3 weeks.
Don't tell me. I forget.
Don't tell me.
Don't tell
Yeah,
me.
be good. Do you mind getting the lights, please? Yeah.
That's nice.
Yes.
And hit the fan on, would you?
No.
Go for one, just one. No, that's 3. That's 0. That's 1. There we go. That's relaxing. Where's Yemi?
Don't know.
Don't know. Oh, you said you saw him leaving the school.
Yeah.
That's right. Okay.
What?
He snuck out.
He bunked the class.
He left the class. He's gone home. They saw him leaving the school.
Why?
I don't know why.
He likes to sleep a lot, actually. Yes.
He's gone home to sleep,
He's
is
my
he?
close friend, yes.
Huh?
What?
Huh?
Can you say again?
He snuck out. You know, snuck.
No.
Like
In a bunk?
like he left the school. So and he didn't want anyone to see him.
He didn't want to see the students, that's why he left.
Yes.
Snuck, sneak. You know, sneak.
Yeah.
Like move quietly.
Oh.
Stuck out.
Snuck out. Yeah.
Yeah,
Yes.
like without
Breakout. Yeah.
New language.
Escape.
No. New word
Yes.
every day.
Yeah, it's good, isn't it?
Yeah.
Can you
Yes.
spell it?
Every day.
S-N?
Now hang on. The problem is huh?
It's not academic word.
Well, of course not. But I'm describing a non-academic situation.
Can you just spell it, please?
Now, just before I do,
Okay.
I think if you're using an American dictionary, snook will be in it, but I don't know if it'll be in a British dictionary. Okay, so what are you just using Google, is it?
No, it's in the, yeah, Google.
Yeah, so, let's see. I hear something I shouldn't hear.
Snog? No.
Johnny? Yeah.
How do you spell
No,
snog?
it's the same, snog. There's no Arabic translation.
Which
Well, I know about different tenses, different tense.
Our times snog is German.
Bunk is
We're putting present tense. Sneak. Oh, sorry. No Arabic for this word either.
No Arabic.
Yeah, sneak.
There is Arabic?
Yeah.
Okay.
Snog?
Yes,
How do you
yes.
spell?
Put in sneak. S-N-E-A-K.
No. Nothing.
S-N. S-N-E-A-K.
What's the Arabic word for snake?
Arabic? Tasallal.
S.
Tasalla.
Yeah, tasallal.
And-
Use it in the war, actually,
E-
always, you know?
A.
Yeah.
Something. Oh, yeah.
To the
No.
side.
It means. Oh, yes. Yes,
And
that's
the
oh.
fashionable food is Irani.
Snake.
Is what?
Irani.
Irani? No, not Iraqi.
Yeah, I asked him.
Not Iraqi, I know that.
He said
You got the word?
Just
Persian,
right
the
there.
Persian.
Are you looking up the word? Or did you know this word already?
I know snake, but not
The one before
It's
it
just
is
the past
Persian.
tense.
No, the
But like I
fashionable
said,
food.
I think it's
Yes,
only
I
past
understand
tense in the
before it's
US. I
very
don't think it's
good.
past
I don't
tense for the UK.
Fashion.
In fact, I think
This
it's
one is
still
also
sneak
basketball, but
for
it's
past
before
tense in the
that one.
UK, and in the US it's snuck. I'm not
There's
sure.
two basketball.
You see
Uh,
restaurants there.
I don't know what dictionary you have. Is it American or is it
Before the
British?
kabalush, I think.
I
Oh,
don't know,
after
I
the
just
kebabs,
found
there's
someone
special
that-
one.
Okay.
Korean.
So after the kebab.
Maybe British.
There's
Yeah.
a
So just type in
barbecue night.
sneak then.
This is
Okay.
No, this is Pakistan.
Have you got? What's wrong?
One of them is
Hey,
Yeah,
where's your physics?
Here.
Oh, come on.
Yeah, true.
Always, yeah.
Well, you give me a good reason to say it. Oh, Quran.
Yes.
In the chemistry class,
Yes.
he said to her,
Yes.
I will kill you if you pick me.
Yeah.
To who?
In front of the lorry.
From me.
You.
Yeah.
Well,
When
you
you
know
ask
what
her
you
the
should
question.
do? You should pick him.
Yeah, she picked me.
Good. Good. Good.
She doesn't afraid of me.
No, she shouldn't be.
I'm choosing who I will choose, and he said something, and then
He said loudly,
Yeah.
in front of the lorry. Pick me, I'll kill you.
Be careful, I will kill you.
no. Oh, come on.
Don't do it again, okay?
Okay, let's do these questions then. So, potential divider. Have you got the question there?
Yes, yeah.
So what information do I give you? I think I give you the voltage, yeah?
Because, no, 220.
Yeah, so it's
This one.
220 volts. Okay, so that's like here. Alright, so what's my first question? I think it's about the copper, is it?
Yes, resistance.
So you have a piece of copper and you make into a resistor. So you need to use this formula. Do you remember this? Yeah, you remember this? Now what do I tell you is this constant? Yeah. Yeah, times 10 minus 8. And what's the length of the
How
copper?
do you find constants?
I was given it. It was given in the question.
No, as in, like, how did you make it real?
Ah, okay, yeah. Well, if you look at this here, you just need to be able to measure the length, which you can do. You need to be able to measure the area, which you can do using, oh my goodness, what's it called? A cap. I can't remember it right now. But there's a small little machine you can use to measure the area of very small wires.
Linear type?
That's the one. Yep, you can use one of those. And you know how to measure resistance? You could use an ohm meter. So once you know those three, you can work out this constant. Yeah. Okay, what's the length of it?
1 meter.
It's exactly 1 meter. Nice.
What?
Yeah.
If the area and the length is changed, the P should be changed, right?
No, in fact, the rho is a constant for the
Oh.
material. Hmm? Yeah. Doesn't change. It's because it's copper, and as long as it's still copper, it stays that value for everything. Yeah. It's like a material constant. What is the area? Or do I give you the radius or the diameter?
You just say millimeter.
For what? The diameter or the thickness? Right. So it's 1 mu meter? 1 micrometer?
146 millimeter.
146. So I must divide by 2, because that's the thickness, and I want the radius.
But why you want the area?
Yeah, so that's pi, or...
I see it's the
Square.
it's square. I see.
Oh, you made it a square,
Yeah.
not a circle.
Circle? Everything.
It should be, because it's a wire, like a string, it should be a circle. No, wait. If you use the square, your answer will be nearly the same. Yeah. Nearly the same. No? Well, you don't know what the answer is because we haven't done it yet.
I don't divide 2.
You don't divide by 2. But that's okay, because if you're making a square, you shouldn't divide by 2. You should just do that squared. Yeah. Anyways, let's see what we get here. Did anybody do it like this?
Yeah.
Well, so what did you do wrong?
Made it square.
You made it a square as well. But like, if you look at this wire, it's a circle.
Yeah, I know. I just.
You had a bit of a breakdown, was it?
Yeah.
Okay, fine. These things happen. Well, you can tell me how close your answer is if you make it a square. Right, what answer did you get, Amanda and KJ, when you made it a square? Wow, that's completely different. I think you made a mistake.
What do you got here?
I don't divide 2. And I don't make this formula square.
You didn't square.
I just make the 146 multiply 146.
No square.
No.
No. Oh, well then, yes, the big problem.
Yeah.
Yeah, because that number was just the thickness, not the area. Yeah. What did you get, KJ? When you did it?
31.5.
No, when you did it at home, what did you get?
When?
When you did this at home, what did you get?
Take home the answer of
Yeah.
the resistance.
Yeah,
31.5.
you got 31.5. Did you make any mistakes? That seems very big. I got answer here of 1.
I got 0.01.
No, when I typed this in, I got 1. No, hang
I'm
on.
typing this actually.
Yeah, when you typed this in, you got 1. And what I want to know is what did you get at home? So you forgot the square. So your answer was very different.
But the thickness is not mean the.
No, if you went with thickness, this you should say is 146 micrometers, and this is 146 micrometers. So if you made it a square, you should have 146 micro squared.
Yeah. Yeah.
Did you square
Change
it?
the unit. Yeah.
Oh, hang on. Okay, hang on.
You should try typing it in.
Okay.
Yeah, Amanda, if you did it, you should have. If you made it a square, you should have got 0.79.
Yeah.
But that's not what you told me.
7.88 point.
Divided.
10
Divide 10 by power minus 8.
multiply 10 over minus 8.
7.
-8. That's too small.
7.
Minus
Just
eight.
like equal 0.79.
How did you get 1?
All right, fine. You did get 0.79 ohms.
Yeah.
That's fine. That's fine. Right, moving on. So,
6, I thought it was 4.
listen. If you make it a circle, you should get this answer, and if you made it a square, you'll get this answer. Okay? But we'll use this one.
Yeah, I know the problem.
What's wrong, Amanda? No, everything is good?
Yeah.
Okay, what I want in part B.
I don't know.
What was my question?
I know the problem.
The
How much
wires
is
is cut in two to make 2 resistors.
Yes.
So the potential divider.
Yes, good.
How much resistance in each resistor?
I said I put in 2.
Yeah.
What else did I say about it?
Nothing.
How much
Did-
resistance
wait,
for
Wait.
each?
Did I tell you what is the output voltage in the
Yeah,
question?
yeah.
So what is the output voltage?
22.
22. Okay, that's fine. All right. So what you have here, if you look, you have your wire. Yes. What's the resistance?
22.
1 ohm. Resistance 1 ohm. And then what you do is you cut it into 2 to make 2 resistors, R1 and R2. So you know that R1 plus R2, what should it equal? 1. Yeah? And you also have this formula. Remember, V out equals R2 over R1 plus R2 times V in. You remember this one? Yeah?
Yes.
You remember.
Yeah.
So here we have, what's it, 22 equals R2. Now what's R1 plus R2? 1
Yeah.
Times 220.
times 220.
R2.
So R2 is 222 divided by 220, which is 0.1, isn't it? So if R2 is 0.1, then what does that make R1? 0.9.
Why are you present nothing.
That's okay. What's part C?
How long is each resistor?
0.5.
What's the length of each one, is it?
Yeah.
Yeah, so we can use this formula, R equals rho L over A, and R equals rho L over A. So we have 0.9 equals, what's the constant? 1 point
6
times 10,
minus
8. Length, and the area is pi, what is it, 146
146.
over 2 times 10 to the minus 6 squared. And here we do the same thing. I won't bother writing it down. So here we get L equals, and L equals Sorry, that's -6, -8 and -6.
Yeah.
That's nice question will come about the exam.
Could be. Like, you know, this is how the exam question usually is by parts like this,
Yeah.
you know. Can you see this okay? I don't think you could, Karar. This here is an 8, and then this one here was a
6.
6.
0.8.
So you should get for L 0.9.
Yes.
And then when you do the same thing here, for this one, you'll get 0.1. But anyways, you don't need to do that because you know the total is how long?
Yeah.
1 meter, isn't it? So as soon as you have this, you know what this answer is. Does that make sense, Grace?
Yes.
Yeah? Once you know that this is 0.9, then this must be 0.1 because the total is 1 meter.
So the R here equal to L.
By accident. I just made it that way. Yeah.
Shouldn't be equal, right?
It won't always be like this, but when I'm making up the numbers, I just pick easy numbers in my head. So it just worked like this. Okay. Can we go on? Yeah. So what do I want in part D? Yeah. What? do I want? Okay. So I'll draw it and you tell me if this is right. So now you have 220 volts, and here is 0.9, and then here is 0.1, and then here is 10. And is my question, what is the voltage in the 10, is it? Probably.
What is the voltage through the large
Yeah.
resistance?
Yes, okay. So what we need to do first is we need to put these together as 1. So we can say 1 over R equals 1 over 10 plus 1 over 0.1. So R equals R equals 0.099. Ohms.
Yeah.
So if I draw it again, it's like this now. 0.9, 0.099, 220, and it goes back here. So I can use my formula again. You know the one V out? V out here equals 0.099 over nearly 10. Yeah, 0.999 times 220. Huh? Yep, 0.999. This plus this. So I get V out equals 21.8 volts. What's wrong, KJ?
Okay, you use the formula.
Is that okay? Is that yes?
Yes. Nothing like. Hope there.
Try to put something in your mind, please.
Yes, there are little something.
Oh, good. I'm glad it's not empty. Okay, is the next part E? Yeah.
Yes.
What do I ask?
Voltage in part B
Yes.
is not 22 volts. Why not?
Yeah. Why not? Why is it not 22?
Why not?
What did you write?
Why not?
Why no? Okay. Why not? Why no? Because. What's the reason? Because when the large resistor is included, that means R2 changes.
And if we change by that much?
Now it's only a small change, but it does make a change. So you know in the formula you have R2 over R1 plus R2. Sorry, that should say V out. This changes because this changes and this changes a little bit. That's why. Yeah? Okay. Can I go down? Yeah. What's F asking?
The lines until the voltage through the large resistor is 22 volts.
Yes.
These are the new resistor R1 and R2.
Yes. So what's happening here for the last, is this the last part?
No.
Oh great. Thought we were-
FGHI.
Oh great, that's great. So F here, what's happened now is you have R1, you have R2, you still have 10, and you want to make it 22 volts here. So you want 22 volts. So we still use our formula. But please be very careful. This here is R1. Can you see that? But these together is the R2 in the formula. So we have V out equals R2 dash R1 dash plus R2 dash V in. So you want 22 equals. Now we have to work out what the total is here. So you know you have 1 over R2, R2 dash equals 1 over R2 plus 1 over 10. And R1 is the same. There's no difference here. So this is R1 dash and this is R2 dash. I'll just give you a minute to make sure you have that clearly written down before I go on.
So what do you mean by R1 dash here?
So what I mean is, in the beginning we have R1 and R2, but later when we add an extra resistor, they're different.
So the R1 will not be.
Now the R1 is not different, but I told you in the question to change it, so the value will be different. So what I mean is, at the start what was R1? I think we said it was 0.9.
Yeah.
So I call that R1, okay? Later, I don't know what it is, I call it R1 dash. It might be a little bit bigger or a little bit smaller. And the reason this is different is because R2 is different. And the reason R2 is different is because now you have an extra 10 on the top. So this one is okay, but I need to work with this a little bit. So let me just take it down here. I have, well, you know what? I think it'd be easier if I write it to the side. 1 over R2 dash equals 1 over R2 plus 1 over 10. 1 over R2 dash equals 10 R2, 10 plus R2, if I add these together.
10 plus R2?
Yeah.
1 plus 10 plus R2.
10 plus R2,
Oh, yeah, yeah,
thank you. R2 dash equals 10 R2 over 10 plus R2. So this is what I want. And R1 dash is just R1 in the resistor. Well, it might be a different number. So, we need this. Be strong. Please, you can do this.
yeah.
Can I go back?
Yes.
Yeah.
Okay, so let's start plugging it in. So what's R1? We don't know. What's R2? 10, what was it? 10 R2 over, no, what was the formula?
10
R
R2
10 over
10 plus R2.
10 R2 over
10 plus
10
R2.
plus R2. And here it's 10 R2 over 10 plus R2 times 220.
Oh.
I know. Also, R1 plus R2 should equal what?
R1? No, R.
Anybody? Anybody?
1.
Thank you.
R is one.
Why? Well, it's still the same piece of wire, just cut in two. So the total is still 1. Okay. Now, maths time. Because you have two equations with two unknowns. See?
Yeah.
We can find the R1 and put the, we can find R2.
Yeah, what way do you want to do it? Do you want to actually write here like R2 equals 1 minus R1 and then put that back in here? Is that what you want to do? We'll do it that way. Yeah, you think so? Yeah.
No, R, the other one.
Hold on. The other way.
So this one.
I don't think we can put it the other way.
Yeah, we can't.
Yeah, it has to be this way.
Yeah.
Yes.
Just go forward.
So let's sub it in and see what we get. So we get 22 equals, now I don't want to write R2 all the time. I'll just write X so I don't have to write R2, okay? So 10X over 10 plus X over 1 minus X plus 10X over 10 plus X times 220. I think
You do the other way. You just change the one R1.
Yes, that's what you said.
I understand what you're saying, Fahad. Sorry, I should have said here 1 and 2 like this. Yeah. Thank you. Huh?
Shall we move on?
Well, we have a tough equation to solve now.
Yeah, sure.
Yes. Very good. Very fast.
Yes. Right, so let's try and solve this now. What do you think would be the best thing to do? I think we should multiply everything by 10 plus x.
10 plus x?
Well, first let me bring this over here, get it out of the way. So we have 1 over 10 equals, and then here I'll multiply the top by 10 plus x, and I'll multiply the bottom by 10 plus x. So on the top I'll have 10x over 1, because this will cancel this. And then on the bottom I'll have 1 minus x times 10 plus x plus 10x over 1. Because I multiplied the top and the bottom by this. So let's see. Now I
have
get,
to multiply the, on the other side too.
not necessary for fractions, I can multiply just the top and the bottom. Don't need to do the same on the other side.
You have only 10x.
Yeah, because this will cancel with
No,
this.
one, you can delete one, right?
Huh? Which one?
The last step.
Here?
1 over 10, the last step,
Here?
the last step.
Here?
Yeah, 1 over 10 equal 10x over 1. You can just write 10x, right?
Oh yes, that's what I'm going to do. Yeah, yeah.
Oh, okay.
Don't worry, don't worry. I haven't gone completely crazy.
Wait. You multiply the top and bottom.
Yes,
Then
by 10 plus x.
the 10 plus x isn't it meant to cancel the 10 plus x at the bottom?
It did, it's gone, it's 1 now.
Yeah, then you now multiply the other side again too. You
Oh,
not multiply the
Hang
two.
on, hang on. Can we watch carefully, please? We're getting very confused.
Yeah.
Watch. So, when, are we watching? When I multiply this by 10 plus x, it will cancel this.
Yeah.
when I multiply this by 10 plus x, this multiplies this and nothing happens, it becomes this. But this multiplies this again, this cancels,
Yeah,
leaving me with this.
Okay.
Are you sure, KJ?
Yeah.
Alright. 10x over, now we multiply this out. 10 minus 10x plus x minus 9x minus x squared plus 10x. 10 minus 9x, is that okay? Yeah. And now I'll get here
Quadratic.
a quadratic 10 minus 9x plus 10x is 1x, isn't it? 10 plus x minus x squared equals 100x. Bring this up here and bring this up here. So I get x squared, and I've got 99 x's, minus 10 equals 0. Yeah, yeah, yeah.
So 2 answers.
Very funny.
Very weird. Yes, x equals minus 99 plus or minus the square root of 9841 all over 2. Yeah, so the first, hang on. So the first answer, so I get x equals 0.1009 or x equals minus 99.101. So which answer do we not use? Well, remember, what does x stand for? It's or 2. So, yeah. Later, okay. We don't use this one.
Really small.
It's too big.
No, this one we don't use because it's negative.
Yeah, it's small.
Yeah, this one we do use.
Okay. And this under the root 989
Huh?
inside the root
9841.
9841.
Yeah. So then the second answer here is 0 for or1 is 8991. That's okay? Yeah. Now, is my next question, what's the length? Or was that, what's the length? What letter is that? G, is it? H? Which letter am I on now? G, is it?
Yep, G.
That was H, was it?
Yeah.
Oh, sorry, of course, I forgot G. Right, G. So, we can use or equals rho L over A. You know? L equals or A over rho. So, for example, the first length would equal, what's 0.1009 times pi 146 over 2 times 10 to the minus 6 squared. What was the constant for the copper?
1.6 into 10 minus
1.68, 10 minus
minus 8.
8. So you'll get here, if you do this, you'll get L1 equals 0.1, oh sorry, that's,
Soon.
what did I put in? That's or2, sorry, L2. So you get L2 equals 0.1009 meters, and then L1 equals 0.8991 meters. Because, you know, L1 plus L2 must equal 1 meter. So it's very easy to get the second answer. Okay, what's the next part? H. Current now. Yeah, current, yeah. So, can I scroll down? Yes?
Sure.
Okay. Okay. What letter?
H.
Yes, H. Yes. So, just a quick drawing again. 220. How big is the first one now?
0.1.
0.8991.
0.8991. And this one 0.1009.
109.
And then this one here is still 10. So what I'm going to do is, I'm going to add these all together to make just one resistor. And then calculate the current in this picture. It's easier.
Otherwise we have to each.
Otherwise you'll have to use Kirchhoff or something. Okay, so I'm going to add these together. 1 over 10 plus 1 over 0.1009. So I get here the R2 total is 0.0999.
Yeah.
And here we can see it's that. So if I just add 0.8991, the OR here is going to be 0.9989, so 999 ohms in total. Okay, what rule can we use to find the current?
Basic rule.
Yeah, which is what? V equals I OR, so then that means the I will equal V over OR, which will equal 220 divided by 0.999, so that would be 220.2 amps.
That's quite a lot.
It kind of is. You wouldn't want to be touching it now.
No.
What's the next part?
That's all.
That's it? What's the
Power.
I? Power. What's the formula for power?
P is equals
IV, which is 2220.2 times 220, which will be 48.4 kilowatts. Is there more?
No.
No.
That's it?
Yes.
Award ceremony.